and tomorrow, as Mr. Budden found out, is a lot of algebra, because he's already doing that tomorrow. Today, hopefully, it's real, not as hard as, tomorrow is kind of hard with all the formulas and equations and such. But today, we're just going to talk about slope. Okay, what's slope in general? What?
M equals y2 minus y1 over x.
Okay, but what is it? What is slope?
It's a fraction. Can be a fraction.
Okay. What else?
You
So-
graph it.
Okay, you graph it. All right. But slope really is the steepness of a line. And it's shown by what letter? Okay, perfect. So in general then, we're going to put these on coordinate planes. And we have two main ways that we can show a slope. The positive slope is going to start somewhere down here in the bottom left and go to the upper right. It does not matter how steep it is. Anything that goes in that general direction is positive. And then my negative slopes are going to start at the top left and go to the bottom right. But again, they could have different steepness, and that's how we're going to get it.
Oh.
What? So from there, then, some of the things that you have to remember, especially when I'm talking about a negative slope, I could say m is equal to negative 1/2, and I'd have the negative sign out in front of my fraction. I could also put the negative on the top or the negative on the bottom. So all three of those fractions mean the exact same thing. In all honesty, when you're working with slope, I would put that negative either on the top or the bottom. Don't put it out in front. The one out in front doesn't mean that both the top and the bottom are negative. It just means that one of them are negative. One negative makes the whole thing. Okay? So, we're going to look at ways of finding the slope from either a graph or finding the slope from any 2 points, and that's what Ms. Schnepp said. So what was your formula again?
M equals y2 minus y1 over x2 minus y1, or x2.
Perfect. And the most important part of this is what? What has to be true on this formula? She said it right, but what has to be true? Yeah, the numbers have to line up on top of each other. Okay? And remember, these are subscripts. This right here is totally different than this right here. Right? This is saying y squared. This is not saying y squared, it's saying y sub 2. We're differentiating between the two y's in this one. This is an exponent. Totally, entirely different things. Okay, so do not write this when you're writing your formula. Now, when I'm talking about my y's on my graph, my y's are always a number that goes up or down, right? When I go up, it's always a positive y. When I go down, it's a negative y. Obviously, then my x's go in the opposite directions. When I go to the right, it's positive. When I go to the left, it's negative. So I can use this formula anytime that I have 2 points on the graph. And I can use any 2 points on my graph. It doesn't matter where they are. It doesn't matter if they're really close together or really far apart. All right? As long as I have 2 points on the graph, it should work. Now, if I am given my So, here's my line, and if they ask me to find the slope, if you notice in my graph here, I don't know if you can see it because it's kind of hard to see, but they actually do show points here. One right there and one right there. So you could use those 2 points, figure out what their actual coordinates are, and stick them into the formula. But if they give me a graph, what's the easiest way for me to find the slope? just count them, right? So if I'm looking at this, like they give it to me, I'm going from one of my points to the other, and I'm either counting straight up, right on that line, and then across. So again, because I go up, that's a positive y, and then if I go left, it's a negative x. So that's why I would get a negative answer for my slope. I could also go from the top and then go down first and to the right. Whoops, I didn't go down far enough. Okay? Either way that you do it, you're going to get the exact same thing. Or if you take those points and put them back into our formula, you're going to get the exact same slope. Personally, if they give me a graph, I'm going to count. Because counting is going to be way faster than doing the math. And I have a lot less chance of screwing up by counting than I do doing the math. Some of you, I know it's hard for you to count also, but it's way better than. So, what's my slope in this one? Can you count there with my third line? 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2. So it'd be what? How about 8?
You're 8. She can't count either.
I know.
Well, I heard you say it again, just listen.
So we would have -4 here. And again, most of the time, as somebody said earlier, it should be a fraction. So you can always write it as a fraction, but if you write it as a whole number, that's totally fine. Most of the time, we stress to always reduce your fractions. In slope, you honestly don't have to, but if your slope is 14 over 6, you might not want to go 14, so you might want to reduce it. It's going to be the exact same answer, it's just going to condense it when you actually have to graph it. Okay? Questions with any of that?
Can I go to the bathroom?
The next part is special lines. I call these special lines because, well, they are special to me. Why are they special? Because I have two options in special lines, but in most cases, if I'm going to graph a line, what equation would I use to graph a line? Y equals mx plus b, and that's including this slope right here, right? So tomorrow we'll get more into y equals mx plus b. Today we're talking about special lines and why these are special to me. Instead of this equation right here, I'm going to have a special line equation. And why it's special is because there's only one variable that's involved. So my two special equations are either vertical lines or horizontal lines. So, when I'm talking about vertical lines, what way do vertical lines go? Up and down. So obviously then my horizontal lines are going to go in the opposite direction, which are left and right. From there though, we got to figure out what variable signifies or tells me that I'm using or will have a vertical line. Is it x equals or y equals some number? So this is x equals plus or minus some number. So then obviously my horizontals are y equals plus or minus some number. But again, notice each one of them only has one variable. So what Bryn was trying to say and what Cadence was trying to say, we're going to show you on a graph, right? So if I came over to my coordinate plane, and again, I don't know how picky Ms. Sarbanal was with coordinate planes. For some of you that have had me before, when you make a coordinate plane to graph, make sure you draw your x and y axis. Make sure you put numbers on it. And make sure you use a ruler and graph paper. Okay? So, if I was going to draw a vertical line, I'm going to look at my green axis, which is my x-axis, right? And I'm going to put a dot right here on -4. To put a vertical line through that -4, I would draw this. And to prove that this line is my -4, if I come up here or right there, or down here on the bottom, what is my value of x every single time? -4, right? My y's change, but just because it's going up and down doesn't mean that I'm associating necessarily with the y. It's associating with going over to that x value and then drawing it up and down. Same thing with the y's. If I go up and down with my y's, I'd stop right here and then I draw a line horizontally. So the question we really want to ask is this. When I'm dealing with this, because we're talking about slope, we want to figure out what is the slope of each of these perfect or special lines. So, don't say it out loud, let everybody have a chance to think. What would you say is the slope of any or every vertical line? So again, this is my line. What is my slope? Everybody got an answer? In your head? What? 0? Why do you say it's undefined? Okay. So, if it's undefined, let's prove it that it's undefined. Tell me this point up here. How much? Tell me another one of those points. I don't care which one. -4, -3. If I put this into my formula, right? These are my y's over my x's, right? When I have back-to-back negatives, what happens? Turns into one positive, and on the bottom I would get 0, right? Anytime 0 is on the bottom of a fraction, what do I get? Undefined. So, that proves that my slope is undefined. Or, we would say, no slope. So, what is my slope for all horizontal lines? Now it's your 0, right? Make sense? So the other way that I like to think about it is this. If I looked out at the horizon, I would look out that way and I would see across, right? So on the horizon, if I decided to become a skier, and I had never skied before, would I want to start on this slope right here? Or would I want to start on this slope right here? God knows that we don't want to do this one, right? So if I was never skied before in my life, and I got up on skis, I could at least shuffle my feet and kind of ski on this slope, right? If I got off the ski lift and got onto this slope, what would happen? If I'd never done it before? We'd probably die, right? So we're going to start out like this, and then the steepness of my slope, as we get better and better, we're going to get more courageous, and our slope's going to get higher and higher. Now, the only people that do this one are Lindsey Vonn and those kind of people. Right? Yeah. Okay? So, that's my steepness of it. But that shows you that we start at 0, and we climb all the way to vertical, which is no slope. Make sense? Okay? Next thing we're going to try to do is graph. So again, tomorrow we'll look into using the formula. Today we're just going to use a point and a slope. So again, to graph a line from some point with a given slope. It doesn't really matter what the two are. So for instance, we have -2, 4, and my slope. So the first thing that I'm going to do is plot my point. So again, we kind of went over what I expect of you to put on your corner plane. So how do I plot -2, 4? Where do I go? Left 2 and up 4. There's my first dot, right? From there, I'm going to apply my slope. Again now, when I'm applying my slope, you gotta remember that the top number is my y's, the bottom is my x's. The top tells me to go up or down, the bottom tells me to go right or left. Again, by the sign. And obviously this is a positive one, so they're both positive. If it's negative, you put the negative either on the top or on the bottom. So when we apply the slope, we're going to do this, and you need at least 3 points. So from my first point, I'm going to apply the slope. My slope in this case is 2/5. So I'm going to go from my point up 2 and to the right 5. And then as number 3 said, I need at least 3 points, so I'm going to do it again. Again, now I get very picky at this. So when you're doing this for your assignment or the quiz or the test, make sure you get a ruler and you connect your dots so it is a straight line. Okay? So we've been doing this for a while now. Is that a line? Why? Doesn't have arrows. So, ladies and gentlemen, on your quiz or your test, if you draw this right here, that's wrong. Because it said to draw a line through it, right? So you got to have arrows on it. If you don't have arrows on it, you will get it counted wrong. Make sense? Now, what happens when I'm going along, because I know this will never happen to most of you because you guys plan ahead and you're always thinking ahead and right? So what happens is, if I draw this first point and I got this next one, and then my piece of paper ran off right there, not that that would ever happen to
Go
anyone.
the other way.
Some of you would try to put it on your desk and then can't figure out why your third point wasn't handed in on your assignment.
Would never.
Right. So, what do?
Go on the other side.
We go on the other side. So, if this is my original slope, and I run out of room, I'm going to change the sign of both the top and the bottom. This is the only time that you'll have 2 negatives in a slope. Alright? So I would go back to my original point, which was negative 2, 4, and now I'm going to apply my new slope, which is negative 2, negative 5. So I come back here, and I go, what? Down 2, and 5 to the left. So we would get right here. But, in either case, if I would have extended my line correctly, and with the ruler, it should have hit that point anyway. Now, if you have an original negative slope, so let's just say my original slope was m equals negative 3/4. When I do this, I'm changing the top and the bottom, so then my negative just really goes to the bottom. But I really changed the sign of both of my coordinates. Make sense to everybody? Okay. Last but not least is this right down here. We've kind of talked about this, I believe, a little bit. Right? Sorry. Parallel versus perpendicular slopes. We've been talking about parallel lines for the whole chapter. What makes lines parallel? They don't cross because why? They have the same slope. So all parallel lines have the same slope. Now, I think we talked about this a little bit the other day, but if I have perpendicular slopes, what's true about them? So, in other words, if I said m was equal to 2/5, what is my perpendicular slope? What? Negative 5/2. So this is, we like to say when we're doing perpendicular, they are opposite reciprocals. And opposite, reciprocal. I don't know if I spelled that wrong. But opposite in this means to change the sign. And then obviously my reciprocal means what? To do it to my fraction. Flipping it over, right? So on your assignment, towards the end it'll ask, are these or do these lines show that they're parallel, perpendicular, or neither. Neither would mean that they cross somewhere. And don't make it a 90-degree angle. Now here's the other thing that you got to think about. When you're doing that part of the assignment, and they talk about you get the same exact slope, is every single time that you get the same exact slope going to show that you have parallel lines? When else would you have the same exact slope? When they're the exact same line, but they're like separated. Right? So if I had this line right here, and this line over here, and they had the same slope, but there was a gap in between them, they're still the same line, because if they have arrows, eventually we would extend them and they would become the same thing. So don't just jump to the conclusion that when you have the same slope, that you always have parallel lines. Okay? Make sense? All right, let's look at a couple examples and then you can have the rest of the time to work. So again, the first part is just figuring out the slope. And you can do that a couple different ways. So obviously, if they throw me something like this, I don't even care where it's at. As soon as I see a horizontal line, I know the slope is what? 0 every single time. Okay? And this is, what would the equation be if I wrote this equation? Y equals -1. Okay? Everybody good there? Here, real quick, if they use the terms rate of change, basically means the exact same thing as slope. So don't get confused if they use that vocabulary. That rate of change would be more for like real world situations and such. And then finally, this is the one that I was talking about. So they're saying determine whether FG and HJ are parallel, perpendicular, or neither, and they give you the points. So again, you could plot the points and just see if they make a line, or sorry, if the two lines cross each other. Sometimes it's hard to draw a straight line though with only 2 points. So in my personal opinion, I would do the formula part here. Stick all my coordinates into the formula and then see about my slope. Okay? But you can definitely just graph them. Okay? So, do you want to see the math? Anybody to this? Everybody good? So, if we go out real fast, let me just show you. This is what their graph would have been like. Right there. So, obviously, might look a little close like it's 90 degrees. So, you might have wanted to do the math at the end either way, but we definitely know that it wouldn't have been parallel. But if you would have looked through the math, it was definitely not either one. Okay? The only other thing, I guess, in this section, there were 2 postulates, but basically the postulates were just being technical way of saying what we said about parallel and perpendicular slopes. So postulate 3.2 said that all parallel have the same slope, and postulate 3.3 says that they're negative reciprocals. I don't like to say negative reciprocals because everybody thinks that it should be negative then. So I like the opposite reciprocal better. So if you want to write those down word for word, they're in the book. But otherwise, basically, we talked about them. We just didn't give them numbers. Make sense? Okay. Any questions for the better of the class? If not, there you go.
Can I have graph paper?